Hey, good evening, everybody. All right, so I don't have a whole lot of time this morning. I'm in here in the shop, but um, come across something here the other day, and um, I thought you guys might be interested in. So, what I thought I would do is make a quick little video since I don't have a whole lot of time this evening or this morning. Depends on whether or not you're a third shifter like I am. So, anyhow, we're making homemade capacitors. And there has been times where, I've needed certain things and what have you. Um, and I wanted to kind of show you guys as far as a couple of DIY homemade capacitors. Now, some of these can actually handle quite a bit of current based on the materials and, your spacing and stuff. Um, and I have used these methods in various situations. But I thought maybe somebody could find this handy, especially where doorknob capacitors, you can't always find exactly what you want on a doorknob capacitor. Now, I'm not saying that the method that I'm getting ready to show you is, ideal for that. There are others that will be. So, but anyhow, what I'm going to actually do here, just finish getting these wires ready here real quick on this. Then I'll pull out some other material as well here behind me. Now, preferably anything that you make a capacitor out of, especially for an RF type application, it's always best that you use material that can be soldered to. So that's kind of what I wanted to practice or focus on there this evening. But anyways, I'm gonna grab one more other type of material here. Good evening time. So one of the first ones, which is one of the earliest capacitors ever used, I think, as far as on radio communications, is what they call the gimmick. And the gimmick capacitor is nothing more than two pieces of wire. And the reason why it's called I shouldn't say the reason why it's called a gimmick. I think the reason why it's called a gimmick, anyhow, has to do with the fact that it's something that you don't think about. Well, anyways, it relies partially on inductance, but can also create capacitance. Now you've got air capacitors or air variables. There again, you can even create your own air variable. They're a little more complicated to do. But they can be made just by using, common everyday things that we would have here. So, as far as to create an air variable, and eventually I may get around to making my own air variable, which is similar to what this is right here. But I use this for tuning for different things because it's got pretty good voltage rating and quite a bit of capacitance as well. But a lot of these things you can actually create yourself just by using common everyday things that you don't really think about. For example, using tubing. You can use tubing. You can use plates of steel if you want. You can use copper, brass. You can actually use aluminum. But anyways, I just wanted to kind of focus on just a couple of quickies here. Like I said, this is called a gimmick, which is just two pieces of wire twisted together. And what's kind of nice about this, and I've used these, and you'll actually see these in prints for like the old Brownings, for example. Those actually, you're going to actually come across, if you ever look inside, you're going to see where you see two pieces of wire twisted together and you think, why in the heck, they just cut something out. No, it's actually a capacitor that's actually in the circuit. So that's kind of what I wanted to show here. Let's undo that here real quick. So, and air is also a type of capacitance depending on how thick the air is today. So let's try to see if this will zero out a little bit better. Right now it's raining, so usually I'm going to be off a little bit. All right, so yeah, it's going to fluctuate a little bit here, but all right. So anyways, I'll just give this a couple of quick turns. Well, hello, Bruce. And I've even used this in modern technology as well. Whenever, I've needed to fine tune something that only just has a couple of a couple of puffs in it. And I actually need to really tweak it down. So, essentially we went from a 0.4 to a 0.7 there. And the more you twist this, once you get to a certain point, it really doesn't seem to matter. But the tighter the twist and the more that you twist this, you're going to see the capacitance go up. Spread back apart here enough to where it doesn't touch either. All right, so basically we went from about a 0.4, which was what it was for the ambient. Now we're up to about a 0.165. There again, that's going to change just a little bit. Some of these are used in keying circuits. I've seen these in keying circuits. I've seen these in tuning circuits. I've used these for trying to get on the old Browning radios. Whenever I used to work on those, you had a small circuit up on top that actually you could go ahead and kind of adjust the capacitance on just a little bit to get the dial to read more properly. So, you had to play with the capacitance a little bit, and the little ceramic tuner on top, you just couldn't get enough one way or the other, and you needed to add some. Well, usually adding a small disc capacitor, even, for the most part, I think the smallest disc capacitor that I carry, is about a 4.7. And, one day I needed something a little bit smaller than a 4.7 and trying to keep some of the inductance down. Well, this is a good way to do that. So, roughly, like I said, you go from about a half a picofarad up to about, 1.7 in this case here. So, that's using, and the thinner it is, and solid copper wire actually works the best for this. I'm kind of limited on that kind of stuff. This is another one that I just kind of twisted, randomly twisted together. The insulation's a little thicker, but I can also twist it a lot tighter. So there, you're going to see roughly around 2.4 here on the meter. But I just thought it'd be kind of a, cool little thing. I said I don't really have a whole lot of time to work on amplifier today, so go ahead and split that apart. I just kind of want to show you guys some of the differences here. But these are called gimmick capacitors, and they work. Depending on what you're trying to do. The insulation is kind of important depending on where you're putting it at in the circuit. This is Teflon wire here. You can use vinyl or PVC type wire for low voltage situations. Basically something that's under 50 volts. So you got to bear in mind what kind of material that you're using when you do that. Another one, and you can actually make a fixed capacitor out of this. And now this is just copper clad board, but I didn't cut these to exact sizes or anything like that. It's just one of those where um, I just kind of wanted to show you guys. And this is a really, really thin. Matter of fact, you can even see through the Teflon. Hello, Joe. So, but I wanted to show you that, you know, and most of the times, as far as mounting something like this, if you wanted to, you can actually layer this, which there again, you know, you can actually put two together this way. Just want to put a piece of ferret on there, just kind of hold some weight on it maybe. But it's only going to use roughly only about a part. So, but you can actually drill a small hole through the middle of this and make sure nothing touches, preferably use some kind of an insulator in between. And let's see. Let's grab the stick here. Now, because this Teflon that I'm using here is very, very thin, you know, you're only looking at a, you know, 100, you know, maybe 150, 200 volts max. But, you know, you can see that, well, we could make a fixed capacitor of about 40 puff. And believe it or not, I've actually made fixed capacitors for the output of an amplifier before because I've needed such an odd size fixed capacitor. I didn't have a doorknob, didn't have the, you know, I didn't have a disc capacitor or anything that was just the right size. You can actually change this by just filing or trimming down, you know, even just one, you know, one portion of it. But we're using, you know, the copper in between there on the copper clad to make this. So there's 40 puff. Another thing you can do is make, and this is stuff that I bought off of Amazon, as far as this real small tube. I was digging for something the other day, and that's what got me kind of started on this little project here, as far as just kind of show you guys the tuning tube. Now, everybody has seen the great big ones that are made of a lot heavier gauge brass, but this can actually hold, you know, about a thousand volts, mainly because of the fact that it's got several wraps of Teflon around it. Even though it's thin, it's several wraps of thin, you know, the thin Teflon. So clip on there, clip on here. You know, there's about 30, you know, roughly around 35 puff. We can slide this out just like any of the others. And now we can adjust it to 12. Grab another stick here. We can kind of hold it down and so if we wanted a 20, 21 puff, 22 puff, you know, it's very easy to actually tune. And where something like this, for example, would be really handy is like for a pass-through tune on an amplifier. You can make this a lot smaller, and you can make it even out of even smaller copper tubing as well. It's just trying to find something that's going to work for the size and everything that you need. But I wanted to show you guys that you can make capacitors at home, even if you don't have what you need. You can make it out of things. You know, go to the kitchen. You can use aluminum, aluminum tinfoil, things like that. You can actually wrap cylindrical versions. There's all different variations of how to make different types of capacitors. But for an RF application, that's kind of what I was kind of sticking towards as far as what I consider the norm. You know, you can take, like I said, small washers and do spacing in between here on something like this and create, you know, your own air variable. You know, the hardest part is the bottom part as far as to make your spacing. But it can be done, using long pieces of like a number 8 or a number 10 uh, all thread or something. If you wanted to actually make your own, you could actually space this out and create a several thousand volt capacitor, that's still adjustable. It'll just take some time to actually make your little foot and all that good stuff, and try to insulate it yourself. So, but like I said, I just kind of wanted to show you that there are multiple different ways of coming up with little things that you might need. Now the other thing too, and going back to making another homemade capacitor, that's one of the other things that I wanted to kind of show you. Like I said, with the copper clad, you can actually flip this over where we've got the physical thickness here, so you don't need as much as what you had a while ago. There's a 1 puff, but that's probably going to be rated at 1500 2000 volts because of the thickness of the phenolic. The larger it is, the more capacitance you're going to create. Another thing that you're going to see this in, and you can actually go ahead and even go one step further, which I don't know if I've got it. Trying to think here what I've got. Yeah. And granted, this is on the floor. So, granted, there again, copper clad in between. If you wanted to, you could actually just solder directly to both sides of this and then start trimming it down. Again, you're going to have to find a way to mount this, which you'd probably want to score the backside or something and put standoffs on it, and then you could solder to both sides of it to make the capacitor itself. Lay that in between there. You're going to see it come down more because we're changing the physical spacing in between our top plate here and our bottom plate. If we wanted to make even loads and loads of, something that's capable of even higher voltage. But another neat thing, like I said, you can actually layer this, if you're using something like copper. And another thing that I've seen these in that's as new as the 80s, can't believe I can't find the edge of that, is copper plates, where you can actually take this stuff and there it is, and start stacking copper in between. You can do a layer of the phenolic, for example, lay this in there, lay a piece of copper over top of it, cut it into a square, cut it into a rectangle. I'm just going to lay this on top of it. This is also another type of Teflon. I'm going to lay this over top of that. Like I said, it's not pretty because these are just all held together by hand. But you can do a layered capacitor as well in a small format. And like I said, we don't have a lot of surface area that we're actually covering right there. But because of the fact that we've layered, thin copper in between, and we've got, 2 pieces insulation and essentially three thin pieces of copper like this, we've created, 30 puff capacitor. Rotate that around there to where we've got a little more surface area covered. Now we're up to almost 37-ish. You got to be careful because otherwise I'm going to wind up grounding out the center piece of that. So I'm just holding this down, that way my fingers aren't part of the circuit itself. But yeah, like I said, if you need to, you can come up with almost anything. For example, I know one of the big ones that a lot of people use is 150 puff. If you cut a piece about 8 or 10 inches long of like the phenolic board, you can actually start layering on top of that, or even something like this strip here, because I use this for repairs and all different forms of things. Some of it I've even got that's a little thicker. Brass shim stock, for those of you that's ever worked in the machine shop, brass shim stock, but you can buy that by the sheet for like a 12, I think it's like 12 by 12 or an 8 by 12 sheet. You can cut it up, you can get it in different thicknesses, and which I really don't recommend going over about 10 thousandths of an inch on the shim stock, because you need to be able to conduct the heat from your soldering iron to be able to solder to it. But you can use the case of your amplifier, for example, for your first layer, and do a bolt on right next to it, and then start stacking up from there. So depending on how much you need, there again, you can keep stacking up. Just make sure that whenever you go to sandwich it, make sure you use some kind of an insulator, or make sure you drill it large enough as far as on the holes that whatever you use for your insulator. One of the things that I like to use, and we can get those out of any junk radio, if I'm doing something small, there again, you can get them in, the plastic, or you can get them in ceramic. But if I'm doing something really small, you can use a 440 screw. You can use the insulator that you use for your transistor, where you got your little foot on there. That way you can catch it good. And there again, I wouldn't want to put a lot of voltage through it, but you could, But it's making sure that everything has plenty of gap in between whenever you go to do something like that, if you're sandwiching. So eventually I'll probably sit down and make one out of some other pieces and parts of scrap, and show you like a sandwich type where I've got it bolted physically together. But for the most part, for every 1,000 volts, you want to make sure that there's at least a millimeter of clearance in between everything whenever you go to do an actual sandwich, if you're going to do a sandwich version. But just using this alone, like I said, is kind of interesting. Since this is double-sided, let's just take our little wires here off. Just playing with scraps today, guys. Playing with scraps. Hello, Chad. Hopefully you're having a great day. Yeah, we're making DIY capacitors. And I'm sure, since you have been in the amp world as well as the radio world, I'm sure that you have seen some of these homemade capacitors that actually work pretty good. I actually seen an amplifier here not too many years ago, but that's what they did because they couldn't find the exact value that they wanted for an output tuning capacitor that was made with the copper clad board because of the thickness of the phenolic. So again, where that's bonded on both sides of it, as far as the copper, like I said, we've just created a capacitor. And in this case, with the random length, we've got a 22 puff capacitor. So, like I said, it's just one of those that I kind of wanted to show you guys where if you wanted to, you could actually put that in there. You could actually start filing down the edge of it. You're going to see your capacitance get smaller and smaller just by making a simple cut, even on something that's bonded like that. You like the little slide tube, do you? Yeah, I've got another one of these that I made that's laying around here somewhere on the workbench, and I can't seem to find it. But this is great for an input tune. Like I said, it's rated for well over 1,000 volts, just because of the Teflon that's inside of it. Just solder the one side down, and like I said, when you need just a fractional amount. But this is stuff that I bought off of Amazon. This one's got several different versions and sizes inside of it here that I just crammed together. But there's yet another couple of sizes yet in between here. Dun, dun, dun. Yeah, it's going to be too small. Oh. Wow. Because I don't want to start cutting all this stuff up because I don't know what I'm going to use it for. This is always the hard part right here, is getting it started. Believe it or not, super glue does help out a lot in this case. Even though super glue doesn't stick, it sticks just well enough. Of course, you can also use a piece of tape to get it started. Like I said, even though this is really thin on the little Teflon wrap that I've got here, which you can get it in various sizes, and I've got some in various sizes. Nah, it's not going to work for me. Let's see, what else have I got here laying around for insulating material? Well, yeah, in some cases it would, depending on just how thin it is. Some of the insulation, like I said, is only good for a couple hundred volts, but you got to wrap it multiple times. I do have thicker, but like I said, it depends on where you're putting it at in the circuit as to, the material that you're going to be using. So, but great for receivers. There we go. Let's just trim some of that down. I think this one's a Teflon and Kevlar, I think. Because I've played with some different exotic materials over the years too, so. Here again, we're actually making this much larger as far as on the difference, so we're making more, more capabilities for voltage just because of the thickness of that. But even though we're just going in there a couple of inches, for example, there's like an 8 puff, and by pulling that out, 5 puff, I'm not sure how far I can go because, like I said, this is pretty small stuff, but you can create a small capacitor in order to go ahead and fine tune something that you only need maybe, 10 or 12 puff adjustment on. Stuff like this is great. Like I said, trim this all down and make it whatever. Of course, we're also adding inductance too because of the lengths of it, but get up here a little closer to that. 7 puff. Probably me just about out of it. Push it all the way in there. So, half an inch or so, we're changing about 1 puff. But like I said, just wanted to kind of show you guys some of the neat little shit that you can do. Yep, doorknobs are great, and doorknobs are getting harder and harder to get at a realistic price. There's the other one. It's on the other tester that I've got. I don't know if you guys can read that one very well or not. That's the reason why I was using the other one, because this meter's not as easy to read on the screen. So, like I said, if you're just needing to just adjust it, fine tune adjust something, you want to make your own capacitor, these are a great little way to do it. All right, guys. Well, like I said, I didn't want to spend a lot of time out here, but I did want to spend some time, like I said, because it's been an extremely busy morning already. Woke up late and a lot of the good stuff, but I just wanted to show you guys some of the neat little kind of a DIY project where if you needed to come up with something unusual that you can't typically get, or if you don't have it on hand, you can actually make it out of stuff that you've got. A lot of the builders, we keep different forms of Teflon on hand. You've seen a couple of them there. Like I said, I keep about 4 different variations. This is some really heavy Teflon. There again, I can use this also for capacitors as well. And that's what I do, is I use this for capacitors. There again, it's going to be a low capacitance because of the fact that my Teflon is so thick. This is like a 0.5 millimeter thick. But again, with being Teflon, it can handle a lot of voltage and a lot of heat. So, and at work, we have high frequency welders. And for the work coil on it, this is about half the thickness of what they use, and they run that welder at about 3,500 volts. So the Teflon itself is about that thick in between the work coil. But you also have to remember now to weld steel tubing together that is nearly an eighth of an inch thick. That's a lot of amperage. So, but there again now on that stuff there, they're also allowing, they're allowing at least 5 millimeters in between the sandwich plates as far as to surround the edges so that it cannot arc across or around it. So, again, it's one of those that you have to kind of, think, think before you just start putting a load to it. But yeah, like I said, just various things, and you can buy all this stuff off of eBay, Amazon. Of course, there are places that sell, specifically this. But like I said, I needed a small capacitor for something the other day. Yeah, I didn't have it, so it's like, well, I've got all this stuff. Let's just sit down and make it real quick. So that's what kind of brought into light, like I said, this little quick DIY project on making stuff like that. That might hold. Yeah, that stuff is actually heavier. Like I said, that stuff's a 0.5 millimeter. But that's actually heavier, heavier than what we use for the tuning tubes that we use every day here. And these are supposed to be rated for about 7 kV. And like I said, the Teflon is about 5 times as thick as what this is. So I'm sure that the other Teflon that I showed you a while ago is going to be able to handle plenty of current. But yeah, like I said, we get these all the time. You'll see these on a lot of different builds. And like I said, it's nothing new as far as the technology. Like I said, it's been there. But instead of using tubes like we do today, generally, back in the 60s and stuff, when we didn't have things like that, and doorknob capacitors were almost unheard of because they were just so astronomically expensive. You'll see where people would use the casing, the casing of a radio, and they would use something as simple as a piece of phenolic like this and cut it whatever length, and they would start trimming it down. They'd go ahead and they'd split it. They'd mount the one side here so that they had a good bolt, and then they would start etching this off a little at a time till they got to the capacitance that they needed. Like I said, I've actually seen that in an amplifier that's ran, several years just by using a phenolic plate and creating a capacitor there for the output. It works. So that's kind of one of the things that, like I said, I just wanted to show you some of the unusual methods that people will use and still use yet today from, the 19, no, as early as I think the 1920s, 1930s. So, but anyways, guys, I'm going to go ahead and get out of here. I'm going to stop and get me something to eat on my way in and go put my time in at the other job. But we will try to get back to this other project here later this week. Like I said, I've got to get back on that Cobra 2000 and get some work done on it. I want to get this finished up. Like I said, I want to get the 2000 taken care of. And then I've got a 1,000 amp power supply that we're also going to be trying to get into the mix here. So anyways, guys, take care. I appreciate it. Just wanted to show you how easy it is to make parts yourself. Have a great one, Bruce. Catch you later. Take care, everybody. God bless, and have a great evening.